Alrighty, happy Wednesday. We're on to part 2 of functions. There's still a lot to do with functions, and there's a lot of cool things we can do with them. We're going to look at a lot of things now, and we're not going to use them all the time in the future, but some people love these little bells and whistles. So just because you can do something doesn't mean you have to. Right, so just keep this in your back pocket, and if you see some code that doesn't look like it makes a lot of sense, it might be doing some of this weird stuff here. And then I guess before we jump into that, one quick thing here is this idea of scope. So scope is where can you use something, and where is it defined, where is it usable. So we looked at, hey, if I want to use a function before I've defined it here, it's going to yell at me. So I could have a function like define Wednesday, and we don't need any arguments, and all it's going to do is print happy Wednesday. And if I wanted to use my Wednesday function here, Wednesday function, Python gets upset with me. It says unresolved reference Wednesday. It doesn't know what this is, so it hasn't been brought into scope yet, so it's not visible. So if after you've defined the function, you can use it. Same thing with variables, right? So if I wanted a variable like my number is 42, I can do that, and after I've declared it, I can use it. Same idea with the function. So I can't go take my number plus equals 10 until I've told Python here's a value. So same idea with the functions. Now what gets weird though is in your functions, you can also use variables that are at a higher scope. So everything that's like left aligned is at the highest scope, right, at this level here. So inside your functions, you can use my number. But now, it's an unresolved reference. It's getting cranky at me here. So if you want, there's, oh goodness, what do we do here? There's a keyword we have to use. I can never remember what it is here. Globals, is it global? Oh, this should have worked. I'm confused. I feel like that one should have worked. Hang on. Print Wednesday, print my number. No. Can't access it as a local. This should have worked. Why did that one not work for me here? This is why it's obnoxious, sorry. It's the global keyword. Tell it it's a global. Global. Yeah. Stuff in the global namespace. So they get put in buckets. We call them namespaces here. So they should be at the global namespace, not local. I don't know why it got put in a weird spot here. More actions. No? None of that was helpful. Globals. What do we get here? So this is all the things in the global space right now. We should have had some variables in here. It has my number. Did I type it wrong? No, I didn't do a typo. All right, well, this is bad practice anyway. Using values outside of your function is generally frowned upon. So if you want a value, you should pass it as an argument here. But it should have worked. That's super weird. We made the globals function. So when it looks to find things, so when you give it a variable, it's looking for anything that's built in, anything that's in the global scope, and anything that's in the local scope. So the built-in things like length, right? We can get the length of a value, length of, which I guess we should have like name is Eric here. We can do the length of name. So length comes from the built-in scope. So that's one of the built-in functions here, and you can see it's the name of the package here is built in. It's one of the built-in ones. So it's just always available here. So when I go use something called length, it knows what that is. If you want, you can do some silly things like length equals 10, and you can print length. And it's going to warn you. It says, hey, it shadows this built-in name here. So you can do bad things in Python if you want to. It's very flexible and lets you do things that are a little bit risky. But now it prints 10 because length was 10. Right? Before I change what length was, if I were to just print len, it says, hey, it's a built-in function called length, len. And that's what we see when we hover over it here. So it's the name of the function here. This is where it's defined. And then if I have other functions, I guess I should put this one up higher. We'll get rid of that here. I can print Wednesday. Now, if I don't use the parentheses, right, this is the name of the function. I'm printing it. I get the same idea here. It's function Wednesday at, and here's this big ugly thing. So best I can tell, this is essentially the memory address. Something similar to that. The fine details of that don't really matter. If you care later on, you can learn what this stuff does, but for our purposes, it doesn't matter. So it says here's the function Wednesday. If I use the parentheses, it's actually going to call the function here instead of just look at the name of it here. And now what I get is none, because my function didn't return anything. Right? Usually our functions would return something or just do something. So if you expect it to return, you're actually getting back this none. It's like, doesn't give you anything back here, but it prints Happy Wednesday, because I called the function at this line here. So it printed it. So it looks in your different scopes. So anything that is built in, you have access to. Anything that's global, and it should have been this, my number was global, but Python's being cranky with me. And then local. So a local scope is something defined within the function. So in here, then I can say, hey, some number is 10. Some number is now a local variable, local to this scope here of the function Wednesday. So outside of this, I don't have access to some number. Right? I can't print some number because it's not accessible at this scope. Right? It was only accessible within this function. It only really exists within that function. One of the cool things Python does is it will clean up. It does memory management, unlike some other languages here. When I use some number, and maybe I want to print Happy Wednesday times some number because we're super excited, right? I'm going to use the variable. So Python will go out and ask your operating system, hey, I need a place to store the value 10. Operating system says, here you go, put it over here. We put it over there. When this function is done, nothing's using that space anymore. Python will eventually go back and tell our operating system, hey, I don't need that space anymore. You can have it back. So that's that automatic memory management. So because I'm not using it anymore, it's going to go away, and I don't have access to it at this level here because it was defined within the function. So we have to be careful when you define things in functions. If you want to use them later, you need to return them. Right? Or you have to go and modify them. There's that, I think I can say it's global some number. I think that's what I can do. There we go. And now I've said, that's the keyword I was looking for. You can say my value is specifically at the global scope, so it's accessible all these other places. It's really messy. Some people love doing it. I'm a big argue against it. It just makes stuff messy. So you can use these global things. I would recommend not. But now I'll have some number here. So I can set some number at the global scope equals 20 here. Oh, not doing it up here? Why is it arguing at me here? Let me define some number without usage. That's fine. I didn't want debug, just run. So we get 20. We go and set it to 10, print it 10 times. We can print some number. Prints out 10. And then, where is it? Is it still, where do we print some number again? We're crashing too many times here. Yeah, prints 10. So it was 10. Print Wednesday. Oh, this is ugly. Let's run a debug mode for fun. right, so we're going to print some numbers. So some numbers value is 20. Right, we set it to 20. Its value is 20. That's good. Now we're going to call Wednesday, so I want to step into the Wednesday function. We set it to 10. Print out 10. We come back. So that some number is still 20. Right, so we have two variables named some number. One at this scope and one at this scope. That's when it hovers over and says, hey, you've shadowed it. We've done a bad thing. We've have a new local variable with the same name. It gets really confusing, sorry. So you can have two different things with the same name if they're different scopes. I guess that's probably the easy way to think of that. So this is now the local scope version, and this is the global scope version here. All right, so if I want to grab some, oh, that's what I have to do. So if I want to grab some number, I think I can put global in. It's a big headache. All right, so these ones are good for namespaces and scopes. So even when we do loops and things, we can declare a value within the loop, and it only exists in the loop, right? Its scope is to this loop. So it's not just specific to functions. It's really anytime you've got an indentation. We've got a scope happening here. All right, and then, all right. Function arguments, we did our arguments, right? Arguments and parameters, we talked about that. You can pass it to things. Now, this is where it gets a little bit weird with Python as well, because we're gonna pass copies of things. Where does this keep crashing here? Name Eric. Oh, because I just stopped, okay. So if I have a value, like, what's a good number to start this value at? 12, okay. So if I have 12, and I'm gonna make a function like add, so we'll define a function for add to, and give it a value here. So I'm gonna take the value and I'm gonna add to it 10, right? That's all we're gonna do with this function. So my value is 12, I'm gonna print value, and then I'm gonna call add to, and I'm gonna give it value, and I'm gonna print value. Right, so let me just run just this bit here. It's not so messy. So the value is 12. We called add to, it added 10 to it, and we printed it out, and it's still 12. Right? When you pass your value here, we're giving it a copy. We're not passing the actual number itself, so we're not changing where this has been stored. So when we get to value equals 12, Python says, oh sure, operating system, give me a place in memory, and stores it out over here. When you call the add to function, it doesn't give it the place in memory. It says, here, I'm storing the number 12, here's your number 12. And now my function has the number 12 stored somewhere else in memory. So when I go modify it, I'm not modifying it where it existed here, I'm modifying the new one I just gave it, because I gave it a copy of that value here. So when we passing, it says passing by value, not the location in memory. So if we think about it, it makes a little bit of sense, right? Because what value is actually storing here is, here's a spot in memory, right? The variable called value is, here's a location in memory the operating system gave me. It's at whatever over here. So when I call my function, I'm not giving it the memory location, I'm giving it what was stored inside of there. I'm giving it the value that was stored there for it to work with. So if you want to change value, really what we need to do then is, we'll do another function, add to and return given value. I can take value plus equals 10, and I can return value. Oh, missing a colon here. So then if I call add to and return, given the value, I'm going to get a number back. So if I want to change the value, I can say value equals whatever I'm getting back here by this return. So now it will say, oh, hey, you're pointed over here in memory, change what's stored here. You were a 12, now you store whatever I just got back here. Here's a new value to put there in memory. So now we're going to have changed it here. Now I can print value. Now it'll be 22 because we've added 10 to it. Now we get the 22 back out because we've stored what we got back. So we gave it a copy, it modified that copy, and we stored the copy. right? Same idea with strings. So if I give it a string, right, strings are immutable. I'm giving it a copy of that string. Right? I'm not changing anything here. So if I wanted to like uppercase, define, let's call this scream in internet, given some string. So we're gonna take some string, we're gonna uppercase it here. So I want some string to equal some string dot upper, right? Uppercase the string here, because this is how we scream in internet land here. We're not gonna change the original string, because strings are immutable, so I could return some string if I wanted. So we had like, name is Eric. Oh, we already had name. How about hello equals happy Wednesday. And y'all are looking too tired here, so we're going to scream it at you here. So I'll say hello is equal to my scream in internet given hello. Let's go change the value of hello. And I can print hello. Oh, I ran the whole thing, sorry. But now I get happy Wednesday in all uppercase because I've changed the value and stored it here. I forgot I had other bad functions in here. Right? If I only just say scream in internet, it's not going to change the value. Even though we're trying to change it here, right? Because it's immutable, it doesn't change. It makes a new string. So whatever hello pointed at over here, it still says happy Wednesday with regular casing here. The new version is a copy somewhere else in memory. So sort of makes sense with values like that. All right. Now, where this gets weird is with lists. So if I have a list of, I always do foods because I'm always hungry. Should we do something other than foods? What about drinks? We'll make a list of drinks here. So of course we have coffee. What else do we have? Water? Yeah, sure, water. Coke Zero. It's an adequate substitution if you can't find coffee. Real Coke will kill me. It's got too much sugar, so it's bad for diabetics. What else? Matcha. Is there a tea in matcha? Okay. Oh, that's good. Tea is acceptable. Right. So now when I have drinks, right? If I were to make a function, and this is what do I want it like? It's a uppercase case list, given some list. Now, I can't just say for value in some list, right? Because I won't change it, right? Because this is essentially already giving me a copy here. But if I go by index, so if I go for index in range, the length of some list here, right? We're going to get out, here's my list at index 0, here's my list at index 1, index 2, whatever I have here. I'm going to take some list at the index is equal to some list at the index dot upper. Whatever it was, uppercase it, store it back in the list here, right? So I'm going to print my list here. We'll print drinks. And then I'm going to call uppercase list given drinks. And now this doesn't even need to return anything here. Right? I'm not returning any values here. I'm just going through, oops, length. I did a bad thing when I called this length over here. I think I might need to comment this one out here. Let me just leave that one commented out. There we go. Now it looks a little happier. Right? And then we'll print our uppercase the list, and then we'll print drinks again. Right? We're not returning any values because when you pass a list, you're passing the value. The value of a list is where it is in memory. Because these things are mutable, it's meant to be changed. It's meant so that you can change it. So when you pass the drinks list to uppercase list function, you're passing here's where it lives in memory. So now you have access to go modify it. Because that is the value of the drinks variable, is actually the memory address. It's kind of crazy. So this gets weird when we start dealing with lists. So lists are mutable and can be changed in functions, right? Strings are immutable and cannot be changed in functions. Right? I mean, you can change it temporarily, but it's not going to do anything here. Did I spell it wrong? 2 M's, there we go. So with a list then, if you give someone your list, they have full access to change it. So we have to be a little bit careful when we use lists because they are mutable, they're changeable, right? Same things works with dictionaries. If you want to pass a dictionary, it's going to be changeable. You can go through and modify the dictionary here. So you have to be a little bit careful with what we're passing where, what we have access to. Even though we're passing by value, the value of it is where it is in memory. That's why it gets a little funny. All right, so function arguments, mutable and immutable, right? That one's good. All right, we did all that. So we can do functions with dictionaries. This is like makes a whole grade book, which is fun. Cool. Other cool things we can do with lists here. Oh, you guys were just doing formatting. This will be perfect here. So if we want to define a function for generate citation here. To generate a citation, you need a couple things, right? You need the author, you need the title, you need the publisher and the year published or something like that, and maybe a bunch of other garbage. Who knows what, right? This will get us started here, right? So that citation then, right, to do it the right order, right, is what? Author's name, comma, the title, or is it title, comma, author? I can never remember here. This is why I always let the tools do it for me. We're just going to print here. So we have author's name, right? We'll do a little formatted string. It's author, comma, the title, and then like a period, and then the publisher or something, and then the year published. I forget here. Something like this. It's not going to be perfect. Don't use this one, right? This is just pretend here. So I can generate a citation. So I can call my generate citation here. I can give it, hey, we'll pretend Eric wrote something here, and it was some code. The publisher was, what, Eric? I guess I'm still the publisher, right? Myself. And the year is 2024, right? Now, PyCharm is being helpful in labeling these things for me. Okay, this one's the author, this one's the title, this one's the publisher, this one's the year published. Not all your tools do this for you here. This is something PyCharm does. It's a pretty nice, handy, integrated development environment, and we like that here, right? So cool. So I can call my generate citation, and we'll get our citation out. Eric, some code, myself, 2024, like we'd expect, right? But other things I can do with this is, because this is a lot of values here, and I might not remember the order here, or I might, you know, and especially if we go and add all the other details we need, you can be specific and say, hey, the title is equal to some code here. The author is equal to Eric Chernesky. The year published is 2024, and what do we have? The publisher is myself. You can name your arguments so that they match here. So usually when we give arguments, we give them in a positional value. So the first one is the first thing, the second one is the second thing, the third one is the third thing. So when we've done that, we've done, hey, I want like range 10, right? We gave it one thing, so we knew what that was. If I wanted two things, right, I can give range two things, the first thing and the second thing. Here's the start and here's the end. And then maybe I can even give it three things. It's step. I want to count by twos here, right? These are positional arguments here. These are named. So we're going by name here instead of by position, because it gets a little awkward sometimes to remember what goes where, right? And I wish range was a little bit better. I think we can say start equals. Will it let us do start? I don't know if it lets us do start, right? 10, 20, and 2. Now, there's only one range function. There's not a range function, so we don't need to have another function like generate citation that takes an author and a title. Like if we only had that information here, right? And maybe we'll just print that. We don't need to make another function here. It's already upset with us here. It's like, oh, hey, you're redefining it here. You're confusing Python. So what you can do is you can have default values for things. So we can have, if you don't tell me, here's title, author, publisher, version, number of chapters, number of pages, sure, why not? So you can use the keyword arguments. Here's the positional ones and default values. So if I want, I can say, hey, the year published, unless you tell me otherwise, I'm going to assume it's 2024. So I can give it a default value. So now I can call my function, and I can say generate citation for Eric, for some code, for myself. And I don't have to give it the year published because it has a default value. So this will still essentially do the same thing here, because it's saying, if you don't tell me what the value is, I'm going to assume it's 2024. Now, range does the same thing here, right? So range, if you just give it one value, that's the end. If you give it two values, that's the start and the end. If you get three values, it's the start, the end, and the step. So step defaults to 1 if you don't give it a value. The start defaults to 0 unless you give it a value. Right? So if you have things that make sense as defaults, you can put them in. So their example here is fun with formatting, a style here. Do you want the American style or the European style? Both of these are wrong. The ISO style is the best style here. But that's okay. We won't complain. So if you mark something as, here's a default value here, a default parameter, you don't have to give it when you're calling that function. So this way you can make your functions a little bit more flexible if some things can have defaults. And sometimes defaults can just be blanks, right? You didn't tell me, sure, I'll just assume it's a blank for now. Right? So maybe the publisher is a blank. Now, what you can't do is put these things out of order. So I can't give author a default and not give title and publisher a default, because we use these positionally. Right? The first thing you give it maps to author. The second thing you give it maps to title. The third thing you give it maps to publisher. How would we know if you gave it author or not if the first one's optional? Right? If I said the first one's optional and you give me one thing, are you giving me the author or are you giving me the title? Right? So the optional parameters have to come at the end of the list here. And as long as they're at the end of the list, that's fine. You can make them optional here as you go, right? And you can make everything optional if you really want to go crazy here. Not really a lot of value in that unless it's a really good default for something like date. Maybe you want to default in the day, but then when you go to run your code tomorrow, the date's going to be wrong. So probably not a good default. Year is even a little iffy here, but that's okay. So if you want them to be optional, right, they have to be at the end of the list here, because we can use them positionally, or you can use them with keywords, right? And I can still use keywords even if they have a default value, which is fun. So default values, function calls, defaults. You can mix and match if you want. Sure, you can make your code look ugly. No one will stop you here. Other cool things, we're not going to do this, just know that it exists here. Are these arbitrary amount of variables here. There's some really cool use cases for it. It's beyond anything we're going to do. So in this example, I'd say, hey, I want some number of other arguments here. Rather than telling me you have to give me a list, you have to give me this, it makes it a little bit easier to use. So it says, okay, you have to give me a bread, you have to give me a meat, and then anything else you want is some sort of condiment, some sort of topping here, right? So for anything else that's in here, I'm just going to throw it in. So I can say I want a sourdough, turkey and sourdough with mayo, or I can want a ham with mustard, tomato, and lettuce on wheat. Right? And it just lets you comma separate until your heart's content. And Python will jam it all into essentially a list called args here. It just makes it a little bit easier for someone to call your function with n number of arguments rather than making them turn it into a list itself. It just tries to be a little bit flexible. You can also do it with kwargs or keyword arguments where you can say, okay, here's the sauce, here's the veggie too. So you're essentially giving it like a dictionary. Here's a key value pair. Again, there's some really cool times you can use this. Most of the time it's not very interesting. And we're not going to bother. But you might see that sort of thing here. For functions, oh, look at that. Mean and standard deviation. You can return more than one value. Now, what's actually happening here is it's doing a little trick here. So generally when we've had return, right, we just put one thing here. Right? So if I wanted to return multiple values here, so define lucky numbers. You don't need to give any arguments here. I'm just going to generate some random lucky numbers, or I'm just going to return 42 and 7. It looks like I'm returning two things, but what Python's going to do behind the scenes for me is turn this into a tuple. So it's really like this, returning one thing. Because remember, a list is one thing, a dictionary is one thing, it just is a collection of others, right? So you can return one thing that happens to hold multiple others. So this is just a shortcut here. So it will automatically pack these, automatically packs into a tuple, basically a tuple. So then if I wanted to get my lucky numbers here, so my, I don't know, lucky number 1 comma lucky number 2 is equal to lucky numbers. So you just comma separate, so I know I'm going to get 2 things back. Now I have 2 variables here, so this is automatic unpacking of a tuple returned. So now I can get 2 values returned from one function, but it's really one value, and Python's just doing a little bit of extra work for you here, right? We could do it the slow way if we wanted, so we could say this is define lucky numbers with tuple, or explicit tuple. So we're going to return a tuple of 42 and 7, right? So in that case, then I can say, hey, I want my tuple of lucky numbers is my lucky numbers with a tuple, and then my lucky number, we'll call this 3, I guess, right, is my tuple of lucky numbers at index 0, and my lucky number, we'll call that one 4, is my tuple of lucky numbers at index 1, right? It just saves me a little bit of typing here. I don't need to go get them out by index here, because it says, oh, the first one is the first index, the second one is the second index, and you can have as many of these things as you want. You can return 27 values here. I don't recommend that, because having 27 variables is probably not very useful off of one function call, but you could. Right? We could generate a whole lotto ticket or do something silly here. So it just is a shortcut for doing it the long way. And that's all it is for us. So it will automatically pack and unpack with our outputs here, which is really fun. This document string is super cool. Doc strings, if you're writing code that someone else is going to be using, right? Generally, I say comments are silly here, but depending on what we're writing here, and if lots of other people are going to use our code, it's worth having a nice comment here, because this will actually show as helper text here. So we'll just steal this one here, because why not? We'll steal their function. I'll feel a little bit bad about it, but that's okay. So here's the function ticket price, and it's just going to print, I don't know, something here. It doesn't really matter what it is. So you give it a description, you give it some arguments, and more information about its other arguments here. So later, if I want to go call this ticket price function here, I'm going to call ticket price, and if I hover over ticket price, it pops up all of that doc string in my little window here, which is super handy. Right? We've looked at some of these doc strings before, like with range. Range has a small little one, create and return a new object. That's not a whole lot of details here. Length has returns the number of items in a container, right? That's the doc string. That's telling us what this function is doing here in a comment that's attached to that somewhere here. So if you're writing functions for other people to use, super nice and handy here. I'm actually I probably shouldn't put their material out on my GitHub. But that's what it looks like in PyCharm. So if you're using an integrated development environment, we get that helper text when we go use our functions. So when we do our functions, it tells us really not much of anything. It says, oh, here's the definition, it's going to return a tuple of int and int. That's all it is here. So you don't get a lot of detail. So you can give more information with those doc strings, which is really nice. And then there's actually a help function that goes and prints that. If you don't have an IDE, you can go and call help. So I think we looked at just briefly this idle environment here. You can just start typing Python. I think this is like the very first week here. So you can say help for length. It returns the number of items in a container. Because if I'm doing this without all of my tools, because I'm crazy and want to, give myself a hard time, you can do it and you'll get some output back out, which is fun. That's what the help one does. All right, so how do we do? Let's see. Oh, nice. We are getting through this. Okay. So back to common errors for functions. This one's nice to look at. If you copy paste things like I do all the time, because all good developers are lazy. It's okay, we're going to copy paste. It's really easy to screw things up by not renaming the right thing here. So this one returns the Fahrenheit calculation here. This one here should return the Celsius, but it's still returning Fahrenheit because we just copy pasted it and didn't change the name here. So code will do exactly what we tell it to do, even if we tell it to do the wrong thing. Right, so that's something we run into a lot with our copy paste errors here. Other return errors here, if we're not returning the right thing, or if you forget to return something here, because you don't have to have return statements, you get that none back. Right? And you can't really do anything with a none because it's nothing. So you gotta make sure you're returning the right value there. Those are some common errors we'll run into, which is fun. Yeah, that was going pretty well. A lot here with this. There's a lot to take in with functions here. Stupid scope. That's obnoxious. So generally, if you want something in your function, pass it. And then if you want to give it back, return it. There's ways you can get around it here. It's just awkward and confusing, and we're going to try and avoid that because we don't want to get in any problems like that. It'll just make life easier for you. Okay. Yeah. I don't actually have too much more now with functions. It's okay if we call a little short today? Okay, cool. So we still have the project, right? That one is due Monday, right? Coming up by the start of class. So if you want to get working on that, I can answer any questions you have on that one. If you want, we can use up our last bit of time for that. And then we're moving on to new things. It goes by quick, right? I'm going to run the report again here. 1% of the participation as they go on. Still 25% for loops. You really, really want to spend your time doing it here. It's worth your practice, worth your time here. You must all think I'm amazing and you can just learn Python from me without having to read the book. That makes me feel pretty good. No, but go read it, spend your time. The practice is very well worth it here, right? That's the only way you're going to get better is by practicing it, and it gets you into some practice here, okay? All right, well, if you don't have any other questions, I will see you Monday then.